Hey, so welcome back, and this is another daily code problem. So today it's called time needed to inform all employees. And so I'm assuming you already read it, but just to quickly elaborate, essentially you're given a particular manager and then a set of people that kind of are informed by that manager or their kind of their direct report. And so basically what you're going to have is it'll define to you what the informed time from a particular manager is to their kind of particular direct reports. And so for this manager, since there's only one layer here, its direct report time is just one. And so to kind of traverse from any of these points from this node to these nodes, it's just going to have a cost of one. And so you just want kind of the maximum time here. And so basically it's going to be one because all of these will just have a one here. But once again, this isn't a good example. A better example would be, say you have nodes like this and like so. And basically imagine that the inform time for these are, okay, the first one is say 2. So to inform its children, it has a cost of 2. Then this one has a cost of say 4. And then this one has a cost of say 5. And so basically all that you want to do is find the maximum. And what that's going to be is, okay, we're going to, when we traverse down here, that's going to have a cost of 2. Same thing here. And then to go down to these children, it has a cost of 4. So once again, 4 here. And these are 5. But once again, you want to sum the total path downward. So it's actually like 2 plus 4. So this is 6. 2 plus 4 is 6. 2 plus 5, that's 7, and then this is 7. And so you just want kind of the maximum of all the total costs. So that would just be 7 in this case because of all the nodes in here and the total costs, like 7 is the most. Okay, so that's kind of the high level explanation, but I'm assuming you kind of already understand the problem. So the implementation, we're going to use a breadth first search solution. So that's going to come from the collections library because we are going to need the double-ended queue here. And I'm going too fast. So we want to import double-ended queue, and then we're also going to want to represent this graph here as an adjacency list. Although it is kind of like what you would call like an n-ary tree, it's just simpler in this context to represent it as a graph problem rather than having like say a class where you define like the node and so forth. So yeah, let's go ahead and do that. So we're gonna also import the default dictionary, and this is kind of just templated code at this point. And so the default value is going to be a list because we want to create an adjacency list here. So we just want to grab all the source and destinations in our manager array here. And so this is just going to say, okay, this particular node is mapped to this particular manager. And so this is kind of the source and this is the destination. And so we just want to say, okay, this manager has access to all of these nodes, and we represent that by saying, okay, at key 2, we're going to have this list of children that it can navigate to. Okay? And so to do that, we just say, okay, let's go through all the source and destinations in our, manager array. And so then we just say, okay, this particular destination can reach this particular source. Now, naturally, at the end of this, we're going to want to return some like max time. So let's go ahead and define that, max time, and it's initially 0. So then we just want to say, okay, while we have something on our queue here, and we're going to initially want to initialize that so that we just specify the head ID and then the particular time that it takes to get there, and that's 0 for the head. Okay, so while we have something on our queue, let's iterate through all of those values. And so what that's going to look like is we're going to want to pop off the current node and then the current time off of this queue. And then we're going to want to say, okay, let's calculate the max time, which is just comparing the current one with the new time. And now we're just going to want to iterate through all of the descendants that it can reach. And we're just going to want to increment that time as we move downwards. And so to do that, we just want to say, okay, let's go through and we want, and this is going to come from our graph here. So at this particular index of this node, we want to know who we can reach. And so let's just say the new node in this adjacency list, and let's say okay. Then we want to append to our queue this new set here, which is then going to be the new node, and the current time added with the time to inform this child from the current node. And so to get that, it's just the inform time at the current node n. Okay, so there might be something wrong here, but we'll see. For S, comma D in manager. Oh, this is just because we want to enumerate it. So this is just kind of a direct access array, they call it. So it just maps directly to the node value, but we want to get the particular source. And so we need to use enumerate here so that we're not just grabbing the manager, but also the source. So that resolves that. Oh, that looks good. And success. So yeah, so for time complexity, well, it's going to be the number of nodes in the graph because you're going to traverse them all at least and at most once. And then same thing with space complexity. So because you're dealing with a queue, you can imagine if the direct reports are kind of like this, then your queue might end up that way. And so that's going to be the space complexity. But yeah, I hope that helped, and good luck with the rest of your algorithms. Thanks for watching.